Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is power of 2. So the problem statement goes like this: you are given an integer n. You have to return true if this is a power of 2, otherwise you should be returning false. An integer is a power of 2 if there exists an integer such that 2 raised to power integer x such that 2 raised to power x is equal to that number that is tested for being power of 2 or not. Okay, and these are some examples. So 2 raised to power 0 is 1, so this is power of 2 indeed, and 2 raised to power 4 is 16, so this is also power of 2, and n is not power of 2 because there does not exist any integer x such that 2 raised to power x equals to 3. Okay, so the constants are as follows: the values of n will be ranging from minus 2 raised to power 31 to 2 raised to power 31 minus 1, and there is a follow-up also that whether you can solve it in without using any loops or recursion for that matter. So we'll be doing it with the most optimal way that can be possible out there. Okay, now let's see how we'll be approaching this particular problem. So first of all, before proceeding with the solution, there is a prerequisite that is to be satisfied in order for you to understand the solution or approach, that is bit manipulation. So if you are new to bit manipulation, then I'll try to provide a link of an article where you can read about it, with what bit manipulation in general is. Okay, other than that, what I'll also give you a brief intro of the approach, how it's going to work in terms of binary representations. So let's start with the approach. So let's say 4 is given to you. Okay, so 4, what will be the binary representation of 4? Okay, 0 0 0 0. Okay, let's mark the bits starting from the 0th bit. This is the 0th bit, this is the first bit, this is the second bit, this is the third bit, and so on. And let's say this is the most significant bit, MSB. Okay, so if you are familiar with binary representation of a number, these are all just powers of 2. Okay, so if a number is a power of 2, then only one bit will be set in its binary representation. So 4's binary representation is this, 2 raised to power 2. So this particular bit is set in 4's binary representation. Okay, and rest all the bits will be unset. So this indicates that this number is a power of 2 because this thing is 2 raised to power 2. Okay, let's say this one was also set 2 raised to power 0, so it's no longer just a power of 2, it's more than that. Okay, that's why only one bit will be set if a number is power of 2 at all. Let's check for 16. For 16, the fourth bit will be set, so this particular bit will be unset. Okay, so 16, as you can see, is also a power of 2. And let's check for 3. 3's binary representation will also have this particular bit as a set bit, the 0th bit. Okay, so if you see that there are two set bits, so this is not a power of 2 because this thing will not be a power of 2. Okay, and instead of this second bit being set, the bit in 3 which will be set is this one. Okay, so this will be 0, and yeah, this one will be set for 3. Okay, this is for 3. As you can see, there are 2 bits that are set. Okay, these 2. So you are able to see that for 3 2 bits are set. That's why it's not a power of 2. Or in more generic terms, you can say there is no integer x which can lead you to this 2 raised to power something x. Okay, but if let's say for 4 there is a integer x which is equal to 2. Okay, 2 raised to power 2 is 4. Similarly for 16, 2 raised to power 4, x is 4 here. Okay, so x is an integer, but for 3 it cannot be the case. So that's why 3 is not a power of 2. And if we see in terms of binary, it will be having more than one set bit. And you may ask, what will be the thing about negative numbers? How will be checking for negative numbers? So what I will tell you is, for negative numbers, first of all, if you go with the binary representation, let's say you want to have a binary representation of -4, this most significant bit is set 1 in negative numbers to indicate that those are negative numbers. And other than that, for negative numbers, they are stored as a form of 2's complement in when they are stored in our system. Okay, so 2's complement. And this representation will for sure have more than one set bit. Okay, so that's why it is we need not to do any checking for how many set bits are there for a negative number. A negative number cannot be power of 2. Okay, so because what will happen in negative number, if we go for the simple binary representation, then the most significant bit will be set, so we need not to check about that. And for 0 also, this 0 also, there will be no bit set. Okay, so this will not be a power of 2 at all. Okay, so we'll be ignoring for negative and 0. Okay, other than that, we can check whether a number is having only one set bit or not. How we can do so? Let's see how we can achieve that. Let's say we are checking for binary representation of 4. So 4's binary representation will look something like this. This is your 0th bit, first bit, second bit, and the third bit. So this is 2 raised to power 2. Okay, 4. So what we'll do is, we will subtract 1 from this 4. Okay, so what will be the number after subtraction? This will be the number after subtraction. Okay, if you do 4 minus 1, which is nothing but it's 3. So 3's binary is this. Okay, 0th bit, first bit, second bit, and third bit. So 2 and plus 1 equals to 3. So after you have done that, you will do AND operation of these two binary representations. Okay, when you will do the AND operation, what you will get? You will get 0 and 0 will 0 and 1 will cancel out. Okay, this is 0, this is 1, so 0, and 0 and 1 will again cancel out, and again 0 and 1 will cancel out, then it's 0. Okay, so you are getting 0. Okay, so if that's the case, that let's say number was 4, then if this thing happens, that number minus 1 and its end with number itself is resulting in 0, then you can say that this particular number is having only one set bit. Okay, this is the logic for only one set bit. Okay, you can call it one set bit check. Okay, and we will be ignoring the numbers which are negative and equal to 0. So number should always be greater than 0. And if these two conditions are being satisfied, then we can safely say that this is a power of 2. So we have to write just this line only, and we are done with the implementation of the solution. Okay, so let's do that. So what we'll be checking is n should be greater than 0, and we'll be returning whether this is resulting into true or not. So n's and with its one less should be equal to 0. Okay, so this condition should be enough for us to check whether this particular number is a power of 2 or not. Okay, so I hope the code is visible to you. Now let's try to submit it, or let's try to submit for the sample test cases before submitting for the final evaluation. So it's getting for accepted for the sample test cases. Let's submit for the final evaluation. So as you can see, it's getting accepted. So this was the whole observation that we were required to make. Firstly, we need to take care of negative and numbers, and the number being 0. So this should not be the case. I told you the reason why this is so, because most significant bit is set in the binary representation, and negative numbers are stored as 2's complement. So the number of set bits will surely be more than 1. So we need not to have any check for that. And for power of 2, only one set bit will be there. Okay, so we need to check whether only one set bit is there or not, and this condition, this particular one, will tell you whether we are having only one set bit or not. Okay, so that's the thing that we applied here, and we got our solution accepted. So if you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.